Now, in chapter 8, there's one grand equation, just like there's one grand equation in chapter 7 that governs work and energy. That equation is the impulse-momentum equation. Impulse changes momentum. Now, if I subtract the initial energy from this equation, I get Werk is what changes energy. And Werk being force times the distance. And you compare that to this equation up here, the difference is that we're talking about the time that the force acts and not the distance through which it acts. Now there's two ways that we typically use this equation in everyday experience. The first way is we have a change in momentum that is fixed. There is nothing we can do about it. You're going 30 miles an hour in your car, you hit a brick wall, the change in momentum is what it is. And we want to minimize the force by stretching out the time. Turn to your neighbor and come up with at least two examples of that from everyday experience where you would lengthen the time to minimize the force. Go ahead. Talk to your neighbor. I will share with you that this shirt is kind of dorky, but it also hasn't always been a good idea. I had an occasion one evening to have this whole room filled with Cub Scouts from Bozeman and their families. And it turns out that their families meant they had little brothers and sisters. And so when I turned around with this shirt, there was just, the mothers were not impressed. It was not good. Okay, what examples did you come up with where you increased the time? Raise your hand, brave soul.
Using your bike brake slowly so you don't flip over your handlebar.
Okay, yeah, there's a couple of ways that you can do your bike brakes. You can just lock them down and go up and over, or you can just gradually do it.
Parachutes when you're skydiving?
Yeah, parachute, okay. You open that parachute, and the longer it applies that force, the bigger your change in momentum. You'd like the change in momentum to be big enough so that you hit the ground at a reasonable rate. Have any of you parachuted? Raise your hand. Yeah, don't do that again. Okay. What else? There was someone over here.
Shock absorbers?
Shock absorbers. That's a perfect example. That's why you have shock absorbers, is so that you don't feel every big jolt in the road. Give you another example. If you're jumping from a height, did your parents teach you to lock your knees? Is that what they taught you? I hope not, because that's just going to shatter your knees. What you want to do is you want to land with your knees flexible to increase the amount of time over which you come to a halt. Likewise, if you're catching a fastball, you don't catch it like that. You catch it like that to increase the time. Give you one more example. Many years ago when we were living in Seattle, a friend called my wife and said, "Hey, we're re-roofing our house next Saturday. Could we borrow your husband?" My wife said, "Sure, I'm not using him," and volunteered me. Now, she forgot momentarily that her husband is afraid of heights. And when I got there, I found it was a 2-story house. So I got up there and I was very nervous. I was crawling around on my hands and feet, scared to death. The manly men who came were just walking around the roof like it was nothing. But one of those manly men had brought his son. His name was Christian. He was about 11, 12 years old. And he felt the same way about that roof as I did. And he was crawling around on his hands and knees and mistakenly crawled onto a piece of sheet metal which turned into a toboggan, and he went down off the roof. Now, as fate would have it, fortunately, he landed on a wooden deck and crashed through the deck. He broke bones, he was in the hospital for quite a while, but he's just fine now. He's he's in his 20s and healthy. Now, if he had landed instead on a concrete pad, that would have been a different ending to that story. It was the time that it took to crash through that wooden deck that saved his life. Now, there's another way to use this equation. There are times when the force that you can deliver is fixed by some parameter that you have no control over. And you want to apply that force for as long as possible to get the biggest change in momentum you can possibly get. An example of this might be the length of a rifle barrel, where you push on the bullet as long as you can to get it going as fast as you can. Okay? With your neighbor, turn to your neighbor and find a couple of other examples of this sort of use.
What do you got?
Well, I mean, it's like you need someone first.
Okay, what did you come up with? Brave soul.
She had a good one.
Cowards, all of you? Oh,
An airplane on takeoff.
an airplane on takeoff. Okay, you want that runway to be longer than 100 feet. You want to just keep on applying that force to get going as fast as you can. Excellent.
Pushing a kid on a swing.
Okay, pushing a kid on the swing. Have you ever done the underdog? No?
Yes.
Wait till you have grandkids. They love the underdog. You just keep on pushing as you go all the way under. Yes, good example, Elizabeth. What other examples? What about the big surgical tubing that you put on those wrist rockets? The slingshots? I mean, it's really, really long, so you pull it back like this so that it's pushing on that rock or whatever you're shooting for a long time. Here's another example. This is just what I've heard. I've heard that if you're in a bar at 2 in the morning and you get in a fight and you can only apply so much force, that you want to keep in contact with the other guy's jaw as long as possible to impart as much change in momentum. Now, I've never been to a bar and I've never been in a fist fight. Just hearsay. Okay? Hearsay. Now,